So we're having the series continuously. Good, everybody. You are all welcome to TPATHS Learning Center. So today is a very important class, and I'll be looking at what I titled 25 popularly asked Jamb questions in chemistry. Now, we noticed something that we decided to prepare questions from last year Jamb questions. And what I would like everybody to know is that we need to know that we need to keep on practicing questions. So I'm going to be doing that once in a while in the series before our exam. We have less than 40 days to Jamb. So we need to know how to practice questions. We need to know how to approach questions. We need to know how to what did this question ask us? What are these questions entail? What are these questions require us to do? That's why I'm going to try to start with these 25 popularly asked Jamb questions in chemistry. So let's start with the first question there. We asked them, what happens to the position of equilibrium if a reversible exothermic reaction is subjected to a decrease in temperature? Beautiful question. We have an exothermic reaction. We need to know something about an exothermic reaction. It's the fact that when we have an increase or decrease in temperature, what happens? You need to know about this. What happens? Now, for increase in temperature, for an exothermic reaction, what happens is that when we increase the exothermic reaction, we observe that the reaction proceeds to the left. And in that case, we have the reactant favored. The reactant is what? Favored. Reactant is favored. But for decrease, reaction proceeds to the left. Sorry, to the right. Right. In that case, product is favored. Product is favored. Product is favored. Now, that is things we need to know about the thermic reaction. So look at the options there. The body equilibrium shifts to the left. For decrease in temperature, no. The equilibrium shift to the right, yes. That makes more sense. So answer number one is what? B. Number two, which noble gas is radioactive and is produced as a decay product of uranium and thorium? Beautiful question. The answer is radon. Radon is, radon has a higher molecular mass. So we observe that when there's a decay in uranium or thorium, radon is a product of such nuclear reaction. So the answer is radon. The next one, which of the following reactions would be expected to have the highest entropy change? Beautiful question. Entropy, what does entropy mean? Guys, ladies and gentlemen, we need to know about this. Entropy deals with what is called disorderliness. That is entropy means what? Occurs or take place when there's what? Disorderliness of the system. Maybe, let's put it in layman English, shambles. Maybe disarray. So that's what we call entropy. And where can we see more of entropy? Entropy can be seen more in gases. The question is why? Why is entropy more in gases? Let's think about that. Why is entropy more in gases? The reason why is because we observe that gas molecules are held by weak intermolecular forces. They are held by what? Weak intermolecular forces. Thus, we observe that the molecules are free. They are free. The molecules are free. Now, since the molecules are free, we observe that since the molecules are free, observe that there's going to be an increase in disorderliness of the system. And that is being favored. Why? Because it is a gaseous substance. Unlike solid. Solid, we see something in solid. We observe that in solid, the molecules are held in a fixed position. A fixed position. A fixed position. A fixed position. So for solid, they are held in what? Fixed position. And since these molecules are held in a fixed position, we observe that the molecules do not move. They do not move. They are in what? Fixed position. Fixed position. I hope that is clear. They are in what? Fixed position. So they do not move. They do not move. And that case, you see it in what? Solids. So now we need to know, where can we see the entropy more? So the best answer is from liquid to gas. I will go with that answer because liquid also have an increase in entropy. So liquid to gas is a very good example of high entropy, or gas to gas. So the entropy should be more as compared to solid to liquid. Or are you going from gas to liquid or gas to solid? No. So the best answer is either liquid to gas or gas to gas. That is the best answer, and that is option A. What is the sum of the oxidation number in a neutral compound? Many people don't know about this. You need to know that when you have a neutral compound like calcium carbonate, what is the sum of the oxidation number of each species involved? The sum is always equal to what? 0. The answer is 0. The sum is always equals to 0. That means in that case, let's say I want to determine the oxidation number of H2SO4 of sulfur. So this is H 1 times 2 plus S plus minus 2 times 4. Why minus 2? Minus 2 is the oxidation number of oxygen. 1 is the oxidation number of what? Hydrogen. But we have 2 atoms of hydrogen, we multiply by 2. We have 4 atoms of oxygen, we multiply by 4. And it always equals to what? The sum is equals to 0. 0. So in this case, 2 plus S minus 8 is equal to what? 0. So S minus 6 is equal to 0, and S is equal to what? Plus 6. This is the reason why it's 0. With that question, the beautiful answer to that question is 0. So we can continue. The answer is C. According to the kinetic theory of gases, the pressure generated by gas is due to very nice question. Very, very nice question. What causes the collision? Number 1, variation of gas particles. No. B, weight of the gas particles. No. The answer will be between C and D. Let's consider molecules of gas in a particular gas chamber. Let me do something like this. Yeah. We observe that this gas, fine, they move rapidly, randomly. But what do we observe? We observe that they do not exert either attractive or repulsive forces. They do not attract themselves. And that is what the kinetic theory of gases. They do not attract themselves, or they do not repel themselves. Now, what do we observe? Is that as these particles are moving in a constant rapid motion, we observe that the molecules of the gas will keep on hitting the container. So that means there will be collision of particles. Collision. And when there's a collision of particles, you observe that this will sum up to what they call pressure. And the answer to that question is what? So due to collisions between particles, we observe that there will be an increase in pressure. That is, you need to know. That is the problem many students do have in Jamb, is that they don't know how to answer worded questions. That's why we are going through it by ourselves here. So you eliminate things that you feel that might not be the answer. And you see me, I had a high success rate in getting the answer because I'm choosing between C or D. Next question here. What is eutrophication? Beautiful question. Now, if you go to the riverine areas where they make, we observe the oil spillage and things like that. We observe that due to the release of harmful substances that may contain trace elements like phosphorus, nitrogen. Now, due to such pollutants in a medium, and medium can be water, and we observe that due to that, we see that when that goes into water, there's what they call an algae bloom. An algae bloom. An algae bloom. An algae bloom. Now, this algae bloom takes place why? Due to the release. So when there is a what? A release of toxic substances, or let me say toxic or trace substances, elements, trace substances that contains phosphorus or nitrogen, what happens? We see algae bloom. So once that is in water, the medium is water, we see algae bloom. Now, algae bloom, what happens in algae bloom is that there is an increase in algae in the water. In the water. An increase in algae bloom in the water. And we know this water contains microorganisms like fish. And in that case, when it contains microorganisms like fish, what happens is that it is starving the fish of oxygen. It is what? Starving the fish of oxygen. So when the algae bloom, when the algae is in water, it starves the fish of oxygen and also has the ability to decay. And when there is a decay of the algae, we observe that there's a decrease in oxygen. Decrease in oxygen. And due to that, we observe that fish in water, they die. They die. They die. Fish in water die. And when they die, we observe that that is not good, because we know that we need abundance of oxygen for mankind. So when this happens, it's not good. So it kills microorganisms in the water, and this takes place because there's a decrease in oxygen, and that is all. This whole process is called eutrophication. 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 So this is very beautiful question. I know questions like this. Beautiful questions. Eutrophication. Now the next thing we need to know is that what is the name of the process by which ammonia is produced on an industrial scale? See the question there. There's what? Nitrification, that is obviously wrong. Nitrogenation, wrong. Ammonia, what is English? What English is this? No, does not exist. The answer is ABBA process. Beautiful answer. Now, the ABBA process, every candidate writing Jamb must know about the ABBA process. And what happens in the ABBA process? In the ABBA process, we have what they call feedstock. Feedstock. What are the feed in this case? The feed here is, let me create something. The feed here is N2, H2. This is the feed here. And the feed, in this case, nitrogen and hydrogen. What happens is that in this nitrogen and hydrogen, you notice something, nitrogen and hydrogen, is that, fine, there is feed. So we have a chemical that is N2 plus 3H2, giving us 2NH3. Now, in this case here, let's look up and understand this gist. Now, this is an ABBA process. And in that case, fine, we all have reactors. So we have this nitrogen, hydrogen being pumped into the reactor. But we need to observe something, that there's a catalyst involved in this reaction. A catalyst involved in this reaction, the catalyst here is what? Is Fe. Some processes do use ruthenium, but ruthenium is expensive. So if you are being asked what catalyst is used in the ABBA process, iron is a suitable answer. So this catalyst is used in the production of ammonia. Ladies and gentlemen, there's something attached to this. Let's get this gist here. There is something attached to this. Fine. In this ABBA process, we are seeing that, the feedstock is nitrogen, hydrogen. What is the catalyst? Iron. We are forming what? Ammonia. Now, we need to know the conditions. That is what I call the reaction conditions that will favor the production of ammonia. What do you observe? Is that this is gas, gas, gas. And one thing you need to know about chemical equilibrium, because this is a more of like a equilibrium process, is that you observe that this reaction, delta H, is an exothermic reaction. Is an exothermic reaction. And you know the exothermic reactions, you need to know about them, is that when you are to favor the amount of products, what will happen is that you have to decrease temperature. That is why you observe that in herbal process, there's always at a lower temperature. And again, lower temperature and high pressure. Why is high pressure? 1.3 is 4, 2. We know when we increase pressure, equilibrium will shift to the side with what? With the fewest number of moles, and that will favor the amount of what? Products. So in this case, high pressure decrease in temperature. So these are the conditions. You can be tested on things like that. So please note that. The next thing again we need to know is who proposed the planetary model of the atom with electrons orbiting around the nucleus. Planetary model. Ladies and gentlemen, we want to take each of them one by one. First one, J.J. Thomson. J.J. Thomson. What is what J.J. Thomson did? J.J. Thomson is credited with some things in chemistry. Number one, he discovered the electron. He discovered the electron. What again did J.J. Thomson do? J.J. Thomson discovered an electron. J.J. Thomson, what did he do again? He discovered the charge to mass ratio of an electron. He discovered the what? The charge to mass ratio of an electron. Now, what else again is that Niels Bohr discovered the planetary model. Yes, the work is Niels Bohr. Niels Bohr is the answer. So he was able to do something that he believed that the electrons will revolve around. He also thought about it that where would the electrons be? He said, oh, it should be around the orbital, revolving around, walking around, and that is what they call the planetary model of the atom. Bohr also thought about it. What is the energy involved here? He discovered what they call the ground state, the what? The ground state, the excited state. He used that to explain what they call the radius of an orbit, energy of an orbit also too. So Bohr did beautiful things. He also said something that in this orbit and orbital, he talked about the spectral lines. And what we all know about, it gives rise to what they call the Rydberg constant. Niels Bohr was a great scientist. We also have the Rutherford there. The Rutherford was credited with the fact that he discovered the proton. He bombarded alpha rays on gold foil. And this is what they call the gold foil experiment. And the Rutherford was, so he discovered the protons there. The next man there's Edwin Schrödinger. Edwin Schrödinger was so obsessed with the fact that everybody was looking for the location of electrons. All before Niels Bohr said about the planetary model of it. And Schrödinger was like, how would I discover this? And was like, oh, okay. He used what they call mathematical expressions to try to locate the electron, which never worked. He used what they call mathematical expressions. That is one funny things. We all thought that is one about mathematics. It's all over the world. So chemistry is central science. So you are applying math, you are applying physics, and various parts in chemistry, in science as a whole. The next thing we need to know is that what happens to the value of the equilibrium constant Kc for a reaction if the reaction is reversed? Beautiful question. Fine. If a reaction is proceeding to the front, what happens is that there will be an increase in the Kc. What is the Kc? Equilibrium constant. But if the reaction is reversed, what is happening is the reciprocal. So it becomes what? Negative. Or A becomes 0, no. Becomes negative, no. Remain the same, no. It becomes the reciprocal of the original value. If it's reversed, now what they call 1 over Kc. 1 over Kc. Ladies and gentlemen, please, let's note that. Please, let's note that. What is the chemical structure of soap and detergent molecules? Very good question. Very, very good question. Now, let's consider something. I want us to look at something. Many people wash clothes every day, and they don't even think that this clothes I'm washing, what is going on in this process? But we as a chemist, we are always curious. You want to know what is going to happen. Now let's look at something. Now let's say I have. Let's say I have. Let me draw it like this. People do call these micelles. Now, what do you observe here? This is called a tail. This is called head. This is called head. Now, the reason why we have head and tail, these are called micelles. I think that they're called micelles. Now, what do you observe here? Is that this article here, head and tail, we need to know why is this possible? Why is this able to work as a soap and detergent? Is that this head is what they call an hydrophilic head. Hydrophilic head. Hydrophilic head. Why the tail is called hydrophobic. 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 I will explain. Now the head does one thing. Find hydrophilic in nature. The fact that hydrophilic in nature means that it attracts water. It attracts water. So the fact that it attracts water, you observe that in a process of soap and detergent, this attracts water, and the hydrophobic tail, what the hydrophobic tail, it will attract oils and greases. Oils and greases, what we all call stains. What we all call stains. So the hydrophobic head, it will not attract no water. No, you don't want water. Don't come here. You don't come here. No water molecule. It will not come here. Once we come to the hydrophobic place is what? Oils and grease. Oils and grease. Don't come here. Water. But I want oil. I want grease. So in the cleaning process, this is what happens. The micelle head will what? We attract water. You, okay, I want water. Water, yes. Water, yes. I want water. You come. So the water comes and it what? Helps in this process of soap and detergent. Beautiful chemistry. Beautiful chemistry. So you need to know this. So somebody ask questions. So you need to know what is the nature of it. Is it hydrophobic? Is it hydrophilic? So I'm very happy that we are able to practice this type of question. Another thing we need to know again is that next question, what is the solubility product used for? KSP. Oh, beautiful. Fine. I have a reaction Ag to SO4. So this is what? 2Ag plus SO4 2 minus. In that case, I have KSP. KSP will be equals to Ag plus all square SO4 2 minus. Yes, I have this, true. But guys, what does the KSP there help? What does it mean? What does KSP mean? What does KSP mean? KSP is an important part in chemistry. KSP. Now, fine. I'm telling that KSP is acting like an equilibrium constant here with respect to solubility. That is beautifully correct. Now, what do you observe is that we have Ag plus square SO4 2 minus. And what do we need to know about this? Ladies and gentlemen, KSP helps us in the fact that let's look at the option before I even say the answer. Okay, to measure total mass of a solid that can dissolve in a solvent, no. That means in that case, we have a solute and a solvent. We all know that a solute and a solvent is what gives rise to what they call a solution. Yes. So now, what does KSP measure? KSP measure the what? The concentration or the equilibrium concentration between when a solid solute dissolves in a solvent in a saturated solution. That means for this to take place, it has dissolved in water. Solid, it will dissolve in water, and this will be aqueous. It have dissolved in water in a saturated form, and that is why you can see the question there. To determine the concentration of a solute in a saturated solution, the answer is B. That is B. The answer is B. Number 12. Which trace gas in the atmosphere plays a significant role in the greenhouse gas? Significant role in the greenhouse gas. The answer is what? CO2. Please, I said that in your note. CO2 plays an important role in the greenhouse effect. Now, the following method can be used to remove temporary hardness from water. It's not chlorination. No. Chlorination does not remove water. Chlorination helps us to what? To purify water. Sedimentation. No. Sedimentation helps us to what? To settle water down and to remove it from there. Filtration, we also do the same too. We are not removing hardness through that process, but boiling, beautiful. Boiling helps in removing temporary hardness of water. Next one, a gas occupies. Now you'll be doing solution solving. Let's solve the question. Let's solve the question. I want to teach you something. So we need to know how to increase our success rate in a question. That is what beautiful, that's what smart students do. Now, a gas occupies a volume of 1.5 liters, V1, at a pressure is 2 atmosphere. If the pressure is increased to 4, P2 is what? 4 atm. While the temperature remains constant, what will be the new volume? V2 is unknown. We can say clearly that this is what? Boyle's law. And in Boyle's law, guys, in Boyle's law, pressure is inversely proportional to what? Volume. That means if pressure should increase, volume will decrease. Let's understand this question there. Guys, let's write the option. A is 6 liters, B is 1.5 liters, C is 0.75 liters, and D is 3 liters. Now, guys, now Boyle's law is P. So if P should increase, volume will decrease. In that case, let's look at the question here. What increased? P1, 2 atm, P2, pressure increase. So if pressure should increase, volume will have to decrease. Volume will have to decrease. That means in that case, V2 will be a value less than V1. So V2 will be a value less than V1. So V1 is 1.5 liters. Let's look at the option. If the value for V2 is greater than 1.5 liter in the option, just fill that question. They don't know what they are saying. They don't know what they are doing. So A 6 liter, go away. B 1.5, go away. D 3 liters, go away. What is the answer here? 0.5 liters. Only one. You are very lucky. Mark it and leave. Don't waste your time. So you have known that you understand the basic concept and it has helped you already. So V2 will be a value less than V1. And the only value less than V1 here is 0.75. But some people feel like we have some doubting Thomas. And that's why we try to solve it together. So let's solve it together so you can see why I said something like that. So let's say in Boyle's law, P1 V1 is equal to P2 V2. V2 will be equal to P1 V1 over P2. And P1, what is your P1? 2 times 1.5 over what is your P2? 4. 2 here 1, 2 here 4, 2. 1.5 times 2, if you do the math, is what? 0.75 liters. Confirm. So that is why sometimes in Jamb chemistry, you don't need to think too much. Apply your principle. And that use someone that is not smart now will be solving, wasting time. But you know the analogy. This is better, you might be lower. Yeah, look, sometimes my doors have they have to solve. In this case, you are very, very lucky. The answer is low, but stainless steel is an alloy made up of stainless steel. You need to know about alloys. Stainless steel contains iron, chromium, and some other elements like molybdenum. They are present too, but the major thing present is iron and what? Chromium. The next one, what is the state of matter in which particles are widely spaced and move freely with high kinetic energy? I've said that today. The answer is what? Gas. Identify the reducing agent in the following reaction. 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 So I'm happy you are making progress. So let's continue. So we have zinc plus CuSO4 giving us zinc SO4 plus Cu. We are challenged here with what? We are challenged here with what is the reducing agent. Let's think. Is this a redox reaction? Yes. What do we know? How do we know it's a redox reaction? Let's get the oxidation number of each of them. The oxidation number of zinc is 0. For copper, is sulfur is 2 plus 2 minus 8, that is what? 6. So this is like copper, this is like you saying copper 2 plus rather. This is copper, this I say 2 plus. Copper is plus 2 here. Zinc is plus 2 here. Copper is 0. We can see that from zinc to plus 2 to what? 0. Now we need to recall an increase in oxidation number, don't waste your time, is what? Oxidation. A decrease in oxidation number is called what? Reduction. Now, you are now asked again, how do we know the reducing agent? Now, zinc undergoes oxidation. Zinc is oxidized from 0 to plus 2. That means zinc is the reducing agent. See here so far, undergoes reduction and it is reduced. This is what? Oxidizing agent. Guys, why are we even stopping safe? We learned from our basic chemistry that what? All metals are what? Are reducing agents. We learned that. Are reducing agents most of the times. So let's look at the option. Let's see if one can work for us like that. So zinc is the perfect answer. We'll stick with zinc. And that is option what? B. The next question, balance the following redox equation. Now in that question, there were options, but I said let me not balance, let me not do the options, let us have the full question because people feel like, what do they do? So what is the balance the following redox reaction? So guys, please follow me in every step of the journey. Now, we have Fe2O3 plus CO giving us Fe plus CO2. Let's identify. This is Fe2O3 to FeCO to CO2. So this is like you having plus 2 to plus 4. This is 0. This is Fe. Let's get Fe2O3. That is what? 2Fe. But the number of oxygen is what? Minus 2 times 3 equal to 0. So 2Fe is equals to we have what? Plus 3. So from plus 3 to 0 is a decrease in oxidation number. This is oxidation. Now let's work. That is Fe2O3. First of all, in balancing, let's balance the atoms of the metal first. Fe is 2 here. We have one Fe. Put 2 here. First. Now, after doing that, you need to balance the amount of oxygen. We have 3 oxygen here. We have 2 Fe here. Now, how do we balance this? We have to balance it using water. 3 moles of oxygen we have here. This is what? 3H2O. Why is it 3H2O? 3 oxygen. So in this case, you have increased the number of hydrogen. So 3 times 2 is what? 6. You add that amount here plus 6H plus. And when we've done that, we need to account for the what? For the number of electrons. So plus 6, we have the total, the net number of these electrons is plus 6. And this is what? 0. So let's make this 0. What do? I'm going to add 6 electrons. And we what? We balance the first one. The second one, CO, giving us CO2. First of all, carbon is balanced. Oxygen is not balanced. So what do? We have to add one more oxygen here. So just add water. Add water. So we added water, we've increased the number of hydrogen here. This is what? Plus 2H plus. It's balanced. So We need to balance the what? Number of electrons. This is plus 2, this is 0. So what do? You add 2 electrons here. Now we have 2, 6, 2, 6. Now since you have 2, 6, we can what? Cancel. Let's make it the same. More like what you do in simultaneous equation. We make this the same. So multiply by 2, multiply by 6. So in that case, we have 12 electrons plus 6 Fe2O3 plus 12 H plus, giving us 4 Fe plus 6 H2O. Then we have 6 CO plus 6 H2O will give us 6 CO2 plus 12 H plus 12 electrons. Ladies and gentlemen, what do? We can see 12 electrons that in opposite side. That's how we can cancel them. When you have number of electrons in opposite side, you can cancel. This is 12, go away, go away. Now you have 6 Fe2O3 plus, okay, this is meant to be 2, sorry. This is meant to be 2. Yeah, it's correct now. So this is what? 2 Fe2O3 plus 6 CO. Now you have H2O here, you have H2O here. 6 H2O, 6 H2O. So this will cancel out. This will cancel out because they're on opposite side. 12 H plus here, 12 H plus here, cancel out. So giving us 6 CO2 plus 4 Fe. And the equation is what? Balanced. Beautiful question. Balanced. So answer might not be like that. Some people, the answer might not be like that. What do? You divide through by what? By 2. So you have Fe2O3 plus 3 CO, giving us 3 CO2 plus 2 Fe. This should be the appropriate answer. But I trust the options. You will not see something like this. You see something like this in the word standard form, the more reduced form. The next question: what is the trend? What is the trend for ionization energy? What is the trend for ionization energy across a period table? Now, ionization energy, we need to know that IE increases across the period, but what decreases down the group. And why? Because as you go down the group, there's an increase in what? Atomic size. That means it's easy for you to remove out an electron from the outermost shell as you go down the group. Because why is it easy? Because the attractive force between the outermost shell electron and the nucleus is weak. In that case, you can easily knock out an electron. That is why IE is low as you go down. But as you go across the period, you are adding one more electron across the period. There's an increase in nuclear charge. And in that case, what do you observe? You observe that IE increases. Ladies and gentlemen, we'll next class. I believe that we really learned a lot today. So I really appreciate our time. We meet next week. Thank you.